first set of lessons are going to be on common logarithms. This set of lessons is going to be broken into two parts. Our objective is I can use common logs. Now, the first part is just to be able to understand the terms and the tools involved with it. And the second lesson that we'll do will involve solving problems with it. So first of all, we need to understand the motivation for it. We have problems like this, log base 3 of 20, that we just don't know how to do with regular exponents. We do know how to do, we've been solving problems like this where we have log base 3 of 9 equal to 2, because we know that 3 to the second is equal to 9. Also, we know how to do log base 3 of 27, that's equal to 3, because 3 to the third is equal to 27. So that's how the logs and the exponentials interact. But log base 3 of 20, we don't know, because what that's asking in essence is, if we want to do this, it's saying 3 to what power is equal to 20? Well, it makes sense that that number is going to be, since 20 is between 9 and 27, that the exponent is going to be somewhere between 2 and 3. Well, how are we going to figure that out? Well, one way is to come up with a logarithm that we commonly use. It's called the common log. So what the common log is if you see a logarithm that's listed like this, where you have log of something, but there's no base listed, that's going to be base 10. It's kind of like what we've done with other situations, like when we do square roots of a number, that's the same thing as having an index of 2. We just don't list it, and so we assume it to be 2. Same thing as with an exponent. If we have a variable with no exponent on it, we assume that exponent to be 1. Well, what happens is when we have a logarithm where there's no base listed, what we're going to define is that is called the common log. It's log base 10 of that number. So when there's no log base listed, it's assumed to be 10. It's called the common log. So let's use that to solve problems. So if we're doing a problem like this one, where let's say that we want to do log, let's do a simpler one, log of 100. That's saying 10 to what power is 100? So that answer is 2. If we want to do log, instead of 1,000, that's going to be equal to 3, because that's 10 to the third power is equal to 1,000. So we're going to use that and be able to solve problems that don't have a nice answer to it by using our calculators. Now let's first of all talk about how the calculator can help us. So using your calculator, it's a tool that we have. If you look at your calculator, you have on your calculator a log key that you can use. So you just have to make sure you look at that log key. It doesn't have a base on it. That's because it's log base 10. So what we're going to do is I'm going to use that to solve a couple problems that aren't quite as quick as log base 10 of, for instance, 100. So if I want to do log of 5, you can do that on your calculator, and your calculator will give you 0.69, let's see, 69897. That's saying 10 to the 0.69897 power is about equal to 5. Okay, so that's where we can use our calculator to do that. Let's try another one. You try this one, see if you can do log of 0.3 on your calculator, see what you get. So what we get when we do that, notice it's a negative because if you think about it, we're going into a fraction, so we get negative 0.5229. Because that's saying 10 to the negative 0.5229 is about equal to 3. 0.3, excuse me. So that's how we can use our calculator to do some of these calculations. Well, the next question is, how do we use that information to help us get one like this, log base 3 of 20, because that still has a different base on it. So we need one more tool. We need a formula, basically a technique that will help us figure out how to do this, and it's called the change of base theorem. This is the critical tool that will help us do problems like this. The change of base theorem tells us that if we have log base b of, let's say, n, that's going to equal the common log of the n over the common log of b. And these we can use our calculator for. So this tool, if you take the common log of the number that's on the inside and common log of the base, that change of base theorem will help us do a problem like this. So let's solve this problem. If we want to do log base 3 of 20, what we can do is log of 20, the common log, and we can do log common log of 3 and see what we get. Let's use our calculator. So first of all, when we put it into our calculator, I'm going to do log of 20, just so we can check what that is. That's going to be about 1.301, etc. And then I'll do log of 3 on my calculator, and I get on that one about 0.477, etc. And so if I take log of 20 and divide by log of 3, what I get is about 2.726, etc. So that's saying 3 to the 2.7268 is about equal to 20. Which makes some sense because that number's between the 2 and 3, which we got earlier in the problem. So change of base theorem can help us find, using common logs, we can find logs of different bases of numbers that don't work out quite as conveniently as we're used to.